Hello, discrete math fans. We're now going to turn our attention to set theory, which we've spent some time discussing, but now we're going to do it in more depth. So the main thing that we want to talk about here is something called the element method of proof. Now let's just remind you about some of the language. The members of a set are called elements. If A is an element of a set S, we're going to use this notation to say that A is an element of S. If B is not an element of S, then we'll use this notation. We're going to have set roster notation to indicate the elements of a set. We've used this before. So, for example, the set whose only members are 1, 2, and 3 will be written with braces and then a 1, 2, and 3. If we have a predicate, P of X, that the elements of S may or may not satisfy, then a set A may be defined by writing A is the set of all elements in S such that P of X are true. And that's how you would read this. Remember, this is talking about the truth set of the predicate. So sets can be created from truth sets. We also talked a while back about what it means for one set to be a subset of another. And we'll write it formally using a universal conditional statement. A is a subset of B. Remember, this is the notation that we used. If and only if, for all x, if x is an element of A, then x is an element of B. All right, so if the universal conditional statement gives us a subset relation, then its negation is going to be an existential statement. A is not a subset of B means there exists x such that x is in A and x is not in B. Notice that what we did here is we took this conditional statement and we negated it to get x is an element of A and x is not an element of B. Remember that negating P implies Q gives you P and not Q. A proper subset of a set is a subset that is not equal to its containing set. So you have to actually be smaller. So we can write that A is a proper subset of B means two things. First, A is a subset of B, and there is at least one element of B that is not an element of A. You see, it is possible that when you talk about A as a subset of B, it could be that they're actually the same set. If A and B are the same set, then you can still say that A is a subset of B. A proper subset indicates that there are actually things in B that are not in A. Now, in order to prove that one set is a subset of another, we're going to have to keep in mind that the subset relationship is a universal conditional statement. And so we can use the method of direct proof to establish a subset relationship. Any proof that does this is called an element argument and is the fundamental proof technique in set theory. We're going to be using this a lot. The way it works is, let's suppose that we have sets X and Y, and we want to prove that X is a subset of Y. So in order to accomplish this, we do two things. First, we suppose that little x is a particular but arbitrarily chosen element of X. And then we have to show that that little x is an element of Y. And we're going to run through a lot of examples of this, so you'll see some examples of how this works. Okay, that's all for now.